Okay, in number 2, we just factor it out. And we think of what factors of 9 add to give us 6. And it's 3 and 3. And since 6 is positive, our 3's are positive. And then we just set each one equal to 0. And so x plus 3 equals 0. And x plus 3 equals 0. And then just solve for x, so you get x equals -3. And since 3 is repeated, we'll just leave it like that. In number 3, we have to get our GCF out first, and 3 goes into each term. And so when we factor out a 3, you're left with x squared minus 6x plus 6 equals 0. And then you can factor it out just like we did in number 2. In number 12, get your GCF out, which would be 2. And so you're left with x squared minus 25. And since we have a difference of perfect squares, it could be x minus 5 and x plus 5. When we set each thing equal to 0, the 2 equals 0 is irrelevant because it's not true. X minus 5 equals 0 gives us x equals 5. And x plus 5 equals 0 gives us x minus 5. So our solutions are -5 and 5. Okay, so in number 24, we're going to subtract 4 on both sides, which gives us 4x squared plus 15x minus 4 equals 0. If we had a GCF, we could factor it out. Since we don't, we are going to use our box method. First in the first, last in the last, and then we have to multiply our 4 to the back, giving us -16. So what factors of -16 subtract to give us 15? And it's going to be 16 and 1. And since our 15x is positive, we want a positive 16 and a -1. So we get 16x and -x. GCF in the first column is x. GCF in the second column is 4. GCF in the first row is 4x. GCF in the second row is -1. So your solution so far, x plus 4, 4x minus 1. Then we set each one equal to 0. This gives us x equals -4. And then 4x minus 1 equals 0. Add 1 to both sides. You're left with 4x equals 1. Divide by 4. And so your solutions are -4 and 1/4. And that's solving by factoring.